What's up, Algebra 2? This video is for our Unit 2B test solutions. Want to go through this and point out some things here so you can continue to improve and become more precise and accurate in writing your answers. Still having some people losing points because they're not writing their answers properly. So let's go ahead and get right into it. Our first one, we just have to pick out which one of these is a solution to this. So let's go ahead. We look at our answers. All of our answers are rational numbers, which means this can be factored. So let's look at this right here. We've got 2 times 3 equals 6. We want two factors of 6 that add up to -7. So we're looking at -6 and -1. So the two factors of this quadratic, x minus 6 and x minus 1, equaling 0, and then we got to remember to divide by a. So we have x minus 3 equals 0, x minus 1/2 equals 0, and we know for our solutions it's going to be the same numbers with the opposite sign, so x equals 3 and x equals 1/2. So x equals 3 is the only one of those that is a solution to that quadratic. All right, the solution set here. A couple of different ways we could do this one. First of all, recognizing that we have a difference of 2 squares, so this factors out to x plus 7. X minus 7 equals 0. Set our factors separately equal to 0. Oops, no. X minus 7 equaling 0. So we have x equals -7 and x equals 7. And we can see the way our solution set is properly written. So we know that's our solution. The other thing, when we have an x squared with no x term, we want to isolate the x squared. So we have x squared equaling 49. Taking the square root, that gives us x equals positive -7. All right, another one, solving our quadratic here. We have the x squared and the x, so that means we need all of our terms on one side set equal to 0. Plus 9x minus 36 equaling 0. We have all integer answers, which means this can be factored. So we're looking at -36. Having two factors that add up to 9, we got to keep in mind our strategy here. That means we're going to have a positive and a negative. So we're looking at +12 and -3. So x plus 12 equaling 0 and x minus 3 equaling 0. So we have x equals -12 and x equals 3. All right, moving right along. All right, when we're talking about describing the roots of an equation, we're talking about our discriminant straight out of lesson 3. Our discriminant we know is b squared minus 4ac. So our discriminant is 3 squared minus 4 times 1 times -7. Which gives us 9 plus 28 equals 37. Positive number, so we know it's not going to be imaginary. And we're going to have 2 distinct real roots. We're going to have a conjugate pair. That is not a perfect square, so that means we're going to have irrational, but this irrational is still real numbers. And as I said, it's what's known as a conjugate pair. Next up, what is the location of this vertex? We are in standard form, so to get our vertex, first of all, we need to know what is our axis of symmetry. So our axis of symmetry, x equals -b divided by 2a. So we have a negative, and b is -6 divided by 2 times a is 1. So that negative becomes a positive. 6 divided by 2 is 3. This gives us the x-coordinate of our vertex. So we can rule out this one here. We can rule out this one here. We can actually rule out this one here. That has to be our vertex. But let's continue on to get our y-coordinate of the vertex. We're looking at y equals, and now we take this value and substitute it in for x, 3 squared minus 6 times 3 plus 10. That gives us 9 minus 18 plus 10 equals 1. And we already knew that it was 3 comma 1. Where does this graph cross the x-axis? So crossing the x-axis, that is our x-intercepts. We are in factored form. Again, reviewing our notes daily really helps. Our factors, where we cross the x-axis, we're going to have these same numbers. Our y-coordinate is going to be 0. We notice how each one of these is written, all right? Each one of these is an ordered pair in parentheses. So we're going to take this number and switch the sign in front of it. So positive 3. Take this number, switch the sign in front of it, negative 5. 3, 0, negative 5, 0. That's simple. Now this one, we want to find the discriminant and the number and nature of our roots. So discriminant, let's go ahead with that. We've already looked at b squared minus 4ac. So now we're looking at negative 6 squared minus 4 times 1 times 10. Gives us 36 minus 40. We have a discriminant of negative 4. What does that tell us about the number and nature of our roots? We have a negative, so we're going to have 2 imaginary roots. Whenever we have imaginary roots, they're going to come in our conjugate pairs, as we've seen before with our plus and minus something I. What are the solutions here? Okay, we've got irrational numbers. So we're looking for a conjugate pair. So let's go ahead with this. We've got negative b plus or minus the square root of b squared minus 4 times a is 1 times c is negative 11. And that is going to be divided by 2a. So this gives us negative 6 is a positive 6 plus or minus the square root of 36 plus 44. All right, getting a little sloppy here. Let's tighten up. Plus 44 divided by 2. So this comes down to 6 plus or minus the square root 80 divided by 2. 80. Can we simplify this? Okay, so we're looking 80 divided by 2 is 40. We're looking for the largest perfect square less than 40 that goes evenly into 80. We know we can forget about 25. We can forget about 36. What about 16? All right, so 80 is 16 times 5. So this comes out to 6 plus or minus. We pull out the square root of 16, which is 4. Square root 5 stays there, divided by 2. We have 6 plus 4 square root of 5, 6 minus 4 square root of 5. But we've got this fraction here. We can simplify this fraction. 6 divided by 2 is 3. Plus or minus 4 divided by 2 is 2. So our conjugate pair is 3 plus or minus 2 square root of 5. So we have 3 minus 2 square root of 5. 3 plus 2 square root 5 is our conjugate pair solutions. Now this one here, we want to use the quadratic formulas to solve this, and now our directions say round solutions to the nearest tenths place if necessary. Okay, so let's go ahead with our negative b plus or minus the square root of b squared minus 4. Now a is -1 and c is 3. All that divided by 2 times -1. So that gives us -7 plus or minus the square root of 49 plus 12 divided by -2. So that's -7 plus or minus the square root of 61 divided by -2. Those are the solutions. This is our conjugate pair, but the directions say round the solutions to the nearest tenths place. So we need to do that. Putting this into our calculator. Actually, no, I didn't want to do that. I wanted to do that. Our answer comes out to, now it does not say put it in brackets, anything like that. So we can just write it as x equals, and what was it? It came out to negative 0.4. I always like to put a leading 0 if my decimal is less than 1, and 7.4 to the nearest 10th. You could have put it that way. You could have put it in the curly brackets. All right, I'm not going to rewrite it. You could not put that in parentheses. If you put that in parentheses, points were taken off. Had to be written according to the directions and properly for a solution set or for the solutions. Okay, moving right along now. Showing the word. All right, which one will have exactly one root? So again, on this one, we need to look at our discriminant. Our discriminant, exactly one root. We're looking for a discriminant of 0, one real root discriminant of 0. So let's look at our first one. Our first one, we have b squared minus 4 times a times c. That is 16 minus 32. That definitely is not going to equal 0. All right, this one here, 4 squared minus 4 times 1 times 16. Now we've got 16 minus 64. That's even further away from 0. It's not that one. Now we have 8 squared minus 4 times 1 times 16. Now we have 64 minus 64, and there we have it. That definitely equals 0. So that is the one that will have exactly one real root. There's another way we could have solved this, but I'm not going to point that out right here, because this one was really about doing the discriminant and remembering and going back to that chart that we had there for looking at our discriminant and using that to determine the roots that we will get on that quadratic. All right, now this one here, solve the equation. Read the directions. It says write your solutions using brackets, which means if you did not use brackets, points were taken off. If you put your answer in parentheses, points were definitely taken off. So let's look at this here. We have the x squared and the x. It needs to be set equal to 0. 3x squared minus 7x minus 6 equals 0. 3 times -6 equals -18. -18, two factors that add up to -7. Remembering back to how we do this, -7 here, means we're going to have -9 and +2. So we have x minus 9, x plus 2 equals 0. These are the factors here. Now our a is 3, so we need to divide by a. And go ahead, x minus 9 divided by 3 is 3 equals 0. X plus 2/3 equals 0. So our solution set is going to be these numbers with the opposite sign, -2/3 and +3. So let's go ahead. Using this, we're going to put our bracket, and we had negative 2/3, comma 3. And that is how you get all 4 points. Or of course, you could have put 3 comma negative 2/3, but I just always like to put my smaller number first. But we definitely have to write it as a solution set in the brackets. All right, same thing here. We have to, hey, see, have to write our solution set in the brackets. Let's go ahead with this one, our square root method. This is straight out of, what was this, lesson 1? Yeah, lesson 1. All right. So first of all, we need to isolate this squared portion because that's where our variable is. Isolating that, let's go ahead and subtract 9 from each side. So we have 1/5, 2x minus 7 squared equals 5. Now let's multiply both sides by 5, clear that fraction. 2x minus 7 squared equals 25. And now we're ready to take the square root of both sides since we have our squared portion isolated. 2x minus 7 equals positive and negative 5. So our two solutions, we need to solve the equations 2x minus 7 equals negative 5 and 2x minus 7 equals 5. This one here, adding 7 all the way across gives us 2x equals 2 and 2x equals 12. Dividing by 2 gives us x equals 6 and x equals 1. So our solutions, we are looking at 1, 6 in the curly brackets to get all 4 points. Okay, moving right along. Now, what is the apparent solution set? All right, so this is where we are connecting concepts that I kept stressing in this unit. We are at -3 and +3. Our solution set is made up of the x-intercepts. So we're intercepting the x-axis at -3 and 3. Easy peasy. Okay, next up. All right, which appears to have 2 distinct real zeros. All right, again, this is about connecting the concepts. Our zeros, x-intercepts, roots, solutions, all refer to the same thing. So in order to have 2 distinct real zeros, we've got to cross the x-axis twice. This is the only one that crosses the x-axis twice. All right, another one connecting our concepts. All right, our x-intercepts are here at -2 and +4. So the factors, in order to write our factors, we're going to use those numbers, switch the sign, and combine it with x to make a binomial. So crossing at -2 and +4, our factors are going to be x plus 2. Now here, they don't necessarily have to be in the parentheses, and x minus 4. Oops, I'm going to write it this way. X minus 4. Okay. Now, I do want to point out the reason I put the parentheses there is because if we look at the factored form would be x plus 2, x minus 4. In the parentheses to show that there's multiplication, we're multiplying these 2 binomials to get the quadratic trinomial for this graph right here. All right, keeping it going. All right, I want to resize this so I can fit more of it. All right. So this one was actually worth 6 points. Switched it, so this one was worth 6 points. All right, let's look at what we have going on here. First of all, our x-intercepts. Well, let's start off. If we want to know our x-intercepts, we need to factor this, if that's possible. All right, so we're looking at -8 -8 and -2. What factors of -8 will add up to -2? Well, -4 and +2. So the factors of our quadratic are x minus 4 and x plus 2, which means our x-intercepts, in order to get all the points for this part of it, we have to write our x-intercepts as -2, 0, and 4, 0. Okay, next up, the y-intercept or intercepts, if we have more than one. All right. Of course, functions can only have one y-intercept. All right, so our y-intercept, we're talking about f of 0. So we have 0 squared minus 2 times 0 minus 8. And of course, if you remember the shortcut that I told you about, once you put in 0, f of 0, it's always going to be, your y-intercept is always going to be that number right there. And we just got to make sure we write it properly as 0, -8. Now for the vertex. We know for our vertex, we want to look, our vertex, we need our axis of symmetry. So our axis of symmetry, we have negative, b is -2, divided by 2 times 1. So we have a negative, -2 becomes a +2. So 2 divided by 2 is 1. Our axis of symmetry is x equals 1. So to get our vertex, we're looking at evaluating f of 1. So that's 1 squared minus 2 times 1 minus 8. Gives us 1 minus 2 minus 8, and that equals -9. So our vertex is 1, -9. Go ahead and put this in here. We are looking at 1. All right, no, there we go. 1, -9. There's our vertex. And we already have our axis of symmetry. Now to finish this off with our sketch. So our sketch, we said our x-intercepts are at -2 and 4. That's way off. All right, let's get this again. We have -2 and 4. Our y-intercept 0, -8. And our vertex at 1, -9. And of course, we're opening up. Our parabola opens up because our leading coefficient is positive. So let's go ahead. We've got come through there, get there, and start to come up. Nope. All right, let me do that one more time. Actually, come down. Oh, there we go. And I guess technically we should put arrowheads. Okay, keeps going. All right, let's go on to our next one here. That was number 16. So number 17. We want to write the vertex form for this quadratic. Vertex form, we're talking about, or we're looking at y equals, it opens up, so it's going to be a positive x something squared and something else. So our vertex 1, 2, 3, 4, our vertex is at -4, -2. So for the x, we're going to change the sign there, same number, so +4. And for the rest of it, make that plus look better. And then for this, we keep number and sign. Now, vertex form equation. To get all the full points on this one. See here. You have to write it as y equals, or f of x equals, y equals, and we have x plus 4 squared minus 2. All right. Now, number 18. This one, domain and range, vertex. Okay, domain. Again, this goes back to the video and the notes. Make sure you're reviewing that. The domain is just straight up all real numbers. Or some people put infinity, figure out a way to put the infinity symbol. But of course, if you do the infinity, it has to be from negative to positive in parentheses. The range, go ahead and use this here. The range, you have to put bracket 3, comma, infinity with parentheses. Or, a couple people put the range is y greater than or equal to 3. Either one of those is acceptable. Now for our vertex here, the vertex, well, we just read that off of this here, 1, 2, 1, 2, 3. So vertex is at 2, 3. Which again must be in parentheses. And the vertex is A. All right, this one right here, again, all of this on here was, let's see, all real numbers, but we already know about domain and range. But that was something straight up off of the notes in the video. The vertex, that's all visual. Look at where the turning point is. The vertex is A. Again, visual. That's the minimum. This is the bottom of it. So the vertex is a minimum. All right, now we're looking at the equation here. All of these, we need to recognize all of these as the vertex form, which again is just the transformation of the parent function y equals x squared. So we're coming over 1, 2, 1. So our vertex is at 2, 1. So we're looking for, first of all, an x minus 2. So we can forget about that and forget about that. So we're looking at x minus 2. And then we're at a positive 1. And again, for the y coordinate, we're keeping the same number and sign. So we're looking for x minus 2 squared plus 1. And that brings us to our last one. Which one of these is a solution? All right, there is somewhat of a, well, let's look at this. Let's just go ahead straight up. One of the shortcuts we could use here is if we just look at our discriminant, that's going to eliminate some stuff here. And actually, we can go ahead and eliminate this one right here. That doesn't look like anything we've ever done. So if we're looking at a multiple choice, or if you're looking at a multiple choice and you see something that we've never done before in class or doesn't look familiar, you can probably eliminate that as an answer choice. That is, if you've been paying attention and reviewing your notes like you're supposed to. All right. Sometimes it'll be like, oh, I've never seen that before. Yeah, we did that. You just weren't paying attention. So that one can be eliminated because 3i minus 2, that's nothing we've ever done before here. All right, so if we go to our discriminant, we are looking at b squared minus 4 times a times c. That's 36 minus 52. I want that to look better. That equals negative 16. So if I'm doing this correctly, negative 16, that's going to eliminate these two. It's got to be an imaginary solution. That one right there. But wait a minute, what about none of the above? So that tells me I need to go ahead and go all the way through with the quadratic formula just to make sure. So let's go ahead. We have negative b, so negative 6 plus or minus the square root of negative 16 divided by 2 times 1. So that's negative 6 plus or minus, all right, we know the square root of 16 is 4, so the square root of negative 16 is going to be 4i. Divided by 2. Now we can simplify this fraction. Negative 6 divided by 2 equals negative 3, plus or minus 4 divided by 2 is 2. Negative 3 plus or minus 2i. So that means which of these is a solution? Negative 3 plus 2i. All right, and there we have it. So we've got to make sure we are very detailed and precise with writing our answers using brackets where brackets are called for, whether it's the curly brackets for a solution set or the square bracket when we're talking about, like with our domain and range. Also making sure we're writing our intercepts as ordered pairs, writing our vertex as an ordered pair, writing our axis of symmetry as an equation of x. So making sure we do not lose points for failure to write an answer properly, accurately, and precisely. All right, well, that's the end of this video right here.